Hello. Alright, we're gonna do some more camping stuff, I guess. Let's do, I don't know, maybe night drive. Something like that. Throw that up there. That worked pretty good last time as far as the what am I doing here? All the music and stuff goes. So I'm just gonna double check that with that stuff out of the way here. This doesn't actually need to be that loud for me. Should be that loud for you guys though. And Brave. Been trying to use Brave browser. Oh shit. What did I do? Sounds like it's a pretty good thing so far. This thing just doesn't want to go to different things here. Oh boy. I love it when I can't move Windows from screen to screen because Windows is garbage. Oh well. There we go. How about we do creator dashboard and manager? Something like that. Bring up my audio here, see if I can hear it well. Man, that is just not loud enough, is it? There we go. Much better. Although it's still quite not quite loud enough. What do we do? I could speak louder, I guess. Go from there. Music at minus 35 is usually perfect. So what are we doing? This morning I worked on a few things. With this fire pit, there was not very glamorous. Didn't really feel like being on camera while I was doing that, so I do have it up on the site though. Give you guys a little rundown with that. This really wants to go to that images thing for whatever reason. Probably the first thing I did. Probably clear the cache for that. That's this guy here. So you get all the plans, everything there. It's $10. That's for the bear. If you want it, I should probably put on the thing. I should probably put on there that you can customize it for whatever you want. Maybe I can probably make it like a subheading or another type of product, because I did a bunch this morning in a bunch of different ways too. So, and hopefully like people will inquire, like just because it's not listed doesn't mean it can't be made, right? I should probably use that as a slogan. Holy shit. Friggin' eyes. And earballs. Yeah. Crusty. Same old story. I don't need to shell. I don't know why I was doing that. So this one here, I put a bunch of designs on these things. So this is just a welded version. So if you wanted this to be I don't know, like permanently there. My brain's starting to stop working. Yeah, then you could just get these panels, get them all cut out, and then do that. So I made a few different kinds with the standard overlap. I can just show you these here. So there's the flat pack fire ring, which was the last thing I did with that one. The verticals. Oh, sorry. It's flat pack here. I need to actually suppress these things here. So I want to suppress these features just so it's flat. This is supposed to be the standard like firing. So standard, I think it looks good just the way it is. Then there's the vertical slats version. So we get that. This is the welded version. It has no corners on it, which I think looks really nice. These are pretty easy to weld. Like if you were to tack that in the middle and then just, or wherever, fold it up, tack them all together, and then just put a few beads on these. They don't even have to be very big. Like you could just weld it here and here, like on the inside and outside, and then just leave the rest of it. Make sure you hit it with some paint, or however you want to do that. And then you can make them thicker too, like if this was 3/16 or quarter or something. If you wanted to weld the whole thing, like, you could do that. And then I can change this so that it's 4 pieces, 3, 4, 5, 6, 7, 8, 9, 10, whatever, however many pieces you want. I just designed it for 6 because I think hexagons look, I think it's like a natural sort of shape. And divides out easily. Yeah, so there's that one. So that's the welded ring. And then these can also be, that's the first one, and suppress. So these can be like that, or a bunch of different ways. So the wavy lines, so there's wavies, the wavy lines. Standard overlap again with these two. I did like a circles pattern. So something a little bit more fun. The diagonal lines, you saw that one. So that's the standard overlap for there. Yeah. And then there's a version of this. I wanted to redo the corners for something that's maybe a little bit, just to look a little bit easier to put together. These are definitely going to be easier to put together, and it has a little bit of a different look. Much less pronounced. I think this actually might look a little bit nicer. But it has, each one has its own charm. And then, yeah, the standard one, and the weld together. And then the weld togethers are, these would be like a permanent sort of install, and then these can be, sky's the limit as far as that goes. So I think I'm pretty much finished with this sort of idea today, although I was looking for other designs to put through other designs to put on this stuff here. Yeah, I don't think I forgot any. So there's the lines, the wavy lines, the wavy, or the straight ones, the straight vertical. There's just the standard plain ones. this type of corner, and then this can also have just plain, which I think is nice and basic. It's these aren't too heavy um, by themselves, so we can do. What are these here? Yeah, they're 6 pounds, 6.5, 6.5 pounds. So you get 36, 39 pounds. So it's not horrible. It is heavy, but like if you're putting it in a truck, 50 pounds is 50 pounds, but like to your truck, it's not much. It's like two things of water, I guess. And then there's this design here. So if you want like a nicer looking, sleeker looking design, I just did this one, so this one like tends to look nicer to me for whatever reason. Um, and then we should do. Oops. I actually originally was going to do a. Yeah, I'll just do this here. So this is the hook type. Until verified that it'll work and work together. I should 3D print some of these. I'll scale them and 3D print them. It'd be kind of fun just to have one kicking around. Yeah, this one looks pretty cool too, and I like the vertical or the diagonal line ones. The diagonal line ones, if you were to like if you're walking up on it, it kind of looks um, like a woven shape, like if you're far away from it. But you might not see that detail, But like that's kind of the idea. So see how you can see the cross pattern, and as you're walking up to it, and you're like, oh hey, that's really neat. But it's like as you're walking up to it, it's more like this sort of idea. So it's really far away on the ground. So I don't know. It's probably not something. You could put all these together and tack weld them too, and they'll stay, especially in the top corners. They'll be fine. So even if you could load this whole thing up with wood and it'll burn down. I decided not to go all the way down to the bottom, just so like if there's a bed of coals or something like that, these will fill up. So I figured, why not? Why not just have this so it gets contained. So in the larger ones, no, not this one. It's the welded hook corners, yeah. So the hook corners and the other one here. I'm sorry, it was just the welded one. These panels here, I decided to do the bottom because then there's like a little bit of an air gap that gets in, but we can put holes or whatever else at the bottom of these. That's what's fun working with a fabricator or like a person that wants a design or something like that. These here, there's no real limit to how many you can put on there. The angle just changes. That's all, a little bit to these, and yeah. All right, so there's that. I was gonna do. What do we got here? Start a new projects. I was thinking about doing one of those tool totes. It's like one of the first projects people usually do for like sheet metal or something like that, like sheet metal practice. And it would be fun to put this up for like super cheap or like a freebie. Kind of like it's one of those sorts of things. Where's the idea list? Yeah, so sheet metal plans. Did I have this in here somewhere? So the fire pit. Oh, an ash pan. Yeah. Toolbox, tool tray. That's what I was thinking about. So the toolbox, tool tray. X toolbox tool tray. So tool tray there, like a tool tray is generally inside a toolbox, but they can be two separate things, and a lot of the times the you'd want to have them separate. So like most people use like a tool bag or like a tool pouch, something like that. Um, it is like a tool bag essentially, or like something you would put in a bucket or something like that. Like, so there's really nice tool bags that you would put all your tools in to organize, and like standard fasteners and like a whole bunch of stuff. So like if you're a tradesperson and you go into a job, you want to bring a bunch of tools with you. You're gonna put it into a bag, but like it should be organized so you know where everything is all the time. And there's some pretty nice there's some pretty nice stuff that's like that. I think my only gripe about that is you always got to put it on the floor and you always got to bend down. But that's just me wanting to be somewhat lazy, I suppose. Okay, so if we were gonna do the basic shape is we have something like that, and then we have, if this needs to be out like that, I get my constraints panel, something like this, probably a lot smaller, maybe like the width of the handle, like an inch, something like that. Everything will scale nice now. Just gonna move this guy over, and sometimes this is, say, like 10 inches or something like that. This could be almost 20, depending on how big of a thing that you wanted. But we can do something a little bit easier, say 10 inches, maybe 3 inches deep, something like that. It would probably be only 8 inches, but I think 10 inches works better. So we have this sort of pattern. These are the ends, essentially. What I'm going to do is, in Fusion, it's easier just to draw everything out. Or like when you're doing sheet metal, it's easier just to draw, I think, like the whole solid piece, and then choose your sides for I'll show you, like, yeah, so you start off with a solid, and then you can either build your whole thing and shell it, which gives you the thickness, or you can, like, I think that's probably the easiest way. And you can do surfaces and then thicken. Sometimes it's a combination of both of those things. So we're going to explore. I've never actually tried to do a fold like this, so I want to try it. It's not going to be 20. We do 24, so it's fairly decent. This bottom tray doesn't actually need to be like that. 8 maybe. There's going to be something in between these two pieces. So if we just did a shell, there's going to be, so think about it being sheet metal. We could use like a 1/4 inch or 1/2 inch. Quarter is probably going to be okay for the outside because we're going to use pretty small sheet metal. So to do metal thickness bend radius charts, there we go. Should have something good here. Do we not have? Nope. That's just geometry. Minimum radius. Oh, it is in geometry. Okay. No. Get out of here. And these kind of give you an idea. A lot of people build this stuff out of aluminum because it's super light, still strong. But if you just did it out of steel, because it's sheet metal, it's not going to weigh that much anyways. So if we could do steel, we could do metric. What we were doing is this inches. Oh, I made it super small. Been doing a lot of stuff in inches, so I'm just going to do inch and pound mass. Pound mass. There we go. I'll set that as a default too. So my sketch is quite small now. Yeah, no big deal. So 1, we're gonna do a 10. Get that to go up here. 8 and 2. There we go. No big deal. No real love lost there. I think the first time I ever made one of these, like out of wood, maybe that was my brother's. I might be remembering wrong. No, my brother definitely made one. So let's do 12. 12 seems like it's a little bit better of a proportion. 10, 12. 8s. Put one for his RC car. I think he used a hockey stick, if I'm not mistaken. It's probably 3/4. And 24 is huge. But it's a tool tray, so we can go from there. So the whole bottom is sheet metal. If we used, depending on what our die is, we're going to have rounded corners here that come around, or actually these will be sharp and then these will be rounded. So let's think about how we actually want this to look. So if we're going to do, this is a bottom continuous sheet. This is going to be continuous, so a fold here, and maybe a fold here as well. And then this is going to fold back and then get riveted through here or something like that. So if we were to look at this in surfaces, I'm just going to delete these so we can kind of get an idea of what the shape is going to look like. All right. So it's going to look something like that. A little bit like that. So open-ended stuff like this is fairly easy to do with surfaces. So I'll show you that first. So, and the reason why, I guess, like when you're thinking about how things curve in, they have a thickness, right? So if you wanted to have like a small gap between here and here, to bend this in, so there's a thickness to that. And we could do this afterwards too. So because Fusion, it's just where do you want to get started with your shape? So I started with this solid. Let's go back. I'm going all over the place. So if we were to shell this at what thickness do you think? Let's do, I'm gonna get rid of that one. So all of the surfaces that are left over are gonna have a thickness to it. Let's do sheet chart millimeters. So just using the, I forgot that you guys can't see that monitor. All right. So we'll do like probably 1 mil or 0.8. 1 mil 0.8. So standard radius. Where's the thing? So this is the minimum amount of die block I think you need. IR 4 to 10 on the inside, and then your minimum for B. Sheet metal thickness, we're gonna do 0.5. So when it's really thin, you can get away with quite a lot. Like this is a really small die, so between 6 and 12 mil, like it's really really small. The minimum or the optimal values for sheet bending. And then this would be the die underneath, and then this is the I forget all my terminology. My goodness. V bending versus air bending. You know, if I just read this, there's this, I'll probably like learn something. No doubt, man. No doubt, Carzy. No doubt. So strange. Well, it's not strange. It just, my brain is weird. And then this is what they're talking about here. So using a small gauge thickness or small gauge material, all the parameters change based on the thickness that you're using, and that's the chart that I was actually looking for. So the inside radius and then the outside radius is the same. It's just you just add the thickness to it. So when you're thinking about outside bends, like those are all outside, so you have to think about what your inside radius is going to look like. So if you use 1 and then I use 1, then I'll get 2 on the outside, and it's just like pretty straightforward. So for this design, I think I will do that. But we could go thinner, like 0.8. I could still do 1, and then it's just 1.8. You know, like, so you're just adding the thickness to the radius. We'll see that here. So let's do 1. This is metric, and I went to imperial for whatever reason. We're going to go down to, I don't know, say 18 gauge or 60 thou. Gauge, yeah, 16, 18, 20 is pretty light. 0.048. So let's do 0.048, and then this is 0.046. Is there something nice? Yeah, 6 and 0.66. I should have just left it metric. That's fine. So 18 gauge, 20 gauge. 20 gauge is really nice and light. Yeah, we'll do 20. Why not? 20 gauge. So it's 0.036. And then we have 0.039. So 0.036. All the way around. So now we have that thickness. So the problem with doing this is, or at least right now, is that we don't have radiuses on anything. So this won't get a radius because that's straight up and down. But these will, all these. Right? So there's a few different schools of thought. You could start out with this shape, and put all the stuff in that you want and cut things, like trim things, because they're sheet metal tools. There's modify tools, right? There's ways to rip. We could actually go through that because I've never really used these things because I just design it in a certain way that I don't need to do that, I guess. So the sheet metal way, we definitely want to explore this for sure. So what I usually do is I use the sheet metal tools. So I have this thing. I get rid of that. I'm going to explode all these. So where's my surface tools? Technically only need to do half of it. instead of doing this, here I'm going to do symmetric and total. So now my origin is in the middle. Or I could just go to one side and do that. That's fine. Let's just do the 112. Negative. Right. Do. Right. So we need to fold all these things. So we're gonna have a thickness here and a thickness and like all this stuff here. And we need to create like space for this. All these could be separate. And again, because this is, we only really need to do half of the other one too. So let's change this up a little bit. We're getting crazy here. Right? So, because we can mirror and then mirror again. Deletes. Schmurp. Right on. Man, this thing is like I've really confused Fusion badly. There we go. Like it was bad. And if you sorry, just texting my mom. Okay. Too late. Yeah. So now that we're here, there's before we do the surfacing tools, we can do our fillets on both sides. And what do we do from this here? So the radius that we're going to use, so it's 0.36 and then 0.039 on the outside. So, or that's on the inside. So we did 0.4. That's going to be the, so this would be the minimum that we need on the inside. So what's the outside going to be? Right, so roughly it's 0.4. If we want to simplify that, 0.4 is fine. Or if you want to stay precise, that's great too. So 0.039, and then you have to add the material thickness to it. And the theory behind the, I guess the theory, the idea behind that is you have a corner, right? And so this is my inside thickness, 0.039. So what I said, yeah, 0.039 inside radius. This is desirable for this sheet metal thickness, 0.039. So when I add thickness to this of 0.036, right, what's my radius going to be? So 0.075. So 0.075. It's like literally just kind of like drawing a circle in there to kind of understand it, because these two, the center points of the radius are concentric, or the radiuses are concentric with each other to maintain, what would it be, linearity, I guess. So if you wanted to say how big is this piece here, it's 0.036 and it's going to be 0.036 and so on and so forth. That's the idea behind all that. Right. So you can just draw stuff out if you don't want to calculate or do things like that in your head. This is maybe the old way of doing CAD stuff. Like I used to just do like quick calculations or use the calculation on the just on the computer, right? I always have the calculator open. So it's like 0.039 plus 0.036. 0.75 is the radius on the outside, so that's what I'll use for this. So I know here is going to have a 0.035 or 0.075 because it's an outside, and this one, but not this one here, right? So now I'm left with these two things. This 2 radius. Is that radius actually going to look like that? Right? No, I don't think so. So if you wanted to do the solids, then you have to actually create the thickness of this and then make the space for it, because how is that radius going to look? It's not going to look right, you know what I mean? So think about how this is flattened out, and then you have this material here, and this has to go in, and that's where this one's going to end, and then it's going to curve into the other way. But it's going to be slightly back, just the material thickness. So we kind of have to like juggle all that around. Like we have to think about what that looks like. So if we go to the surface, here, you, and you, just delete all that. And then we can remove all these to here. How much space are we going to need between here and here in order to make that round? Or what do we even want this to look like? So that's another sort of idea. So we have a thickness. So we could leave this for now if you just want to leave this one off. I'm getting ahead of myself here. This is going to be attached to here in its thickness, but we need to make a gap on that. How big is the gap? Well, like how much of everything? How do we derive that information? So we should probably do that. We have a timeline that we can work with in Fusion, and we can make sketches, and we can do all this stuff. So how do we get to that like corner situation that we want for that? And then maybe the easiest. So let's try that. So now I purposely put these two back together because I can actually do that, this particular radius, 0.075. So now we have something that we can use, because we know that this is going to have these two things, and then this is going to have a thickness, and we know what that thickness is going to be as well. So we use that. So this thing here, how far back do we need to come? So we can make a sketch on this because it's a flat plane. And we can say, okay, let's project this one piece here. It could be the other side too. It doesn't have to be that one. Let's do that. So we have this piece in the corner. We can turn that off. We can project these two as well. Or we can just, go from here. Sometimes it helps just to do the whole thing. Let's project you, you, and you. Right, so we got those, and it has a thickness, so 0.039. We can just verify real quick in the bottom corner over here, 0.036, which is what this is here, 20 gauge, 0.036. So that's where the inside line is going to be. Then we probably want just a little bit of clearance. I don't know. Jeez. Upsy downsies. Point 10 thou maybe, something like that. So this is where this thing is going to come in, but we got all this stuff that we don't really want. We need clearance for in here, right? So 0.039, we have this shape here, all that, but now we're gonna have, it's the same thing as this corner. It's like literally this. We're looking, so if you were to take this box and look on it, like straight on it, so look on it like this, right? This is the corner that we're actually looking at. So there's the thickness, there's the gap, and now this thing is gonna have this rounded edge here. So how far back do we need to keep this? Right, for the thickness. But we don't actually need to do this particular one yet. We just need to say, where is this going to go? And I'm pretty sure that's what the rip does for us. We can look into that a little further. We're just going through the sheet metal manually, as if none of those extra tools existed. That sort of idea. So we have this total radius is how big? So it's the same. It's 1.7 or 0.075. So that's how far back we need to actually have this one piece here. So that's horizontal, vertical. Keep that. This is just a construction line and a clearance dimension. Make this look a little nicer here. In case anybody decides to come in here and look at my stuff. So because we have this reference dimension, we can just use that directly. So between here and here, just make it that reference dimension. I remember when Fusion actually didn't have that. It was so bad. It was a sad time. Okay, so now we have this dimension. It's locked in, and we can trim this thing. Oops. You can trim using this, and which side do we want to trim off? It's that one. Turns red, and that's good. Right. So, and this is the location where we want that at. So now we can add this back in. We're gonna do that. Should not be stitching like that unless I cut it shitty. No. I'm gonna delete these and do all that afterwards. I shouldn't though. I shouldn't have to. That's weird. Weird. Let's see if this breaks. 0.0, what did we say it was? 7.5? Yeah. See, it's not going to do this because now we need to have some sort of clearance. Even though this is here, this one's not going to, it's not going to play nice with us. So, to hell with it. When you come across situations like this, doing CAD work, if you've never done it before, because I've never actually done this corner specifically like this before. I always stop and then use the sheet metal tools afterwards because it's just a little bit easier. But I like to explore stuff and trying to learn things. How do I get this to look? A lot of the times to get the joints, I just do like a miniature quarter fillet through here. Do the shell. I have these two things here, and then it kills the corner for me. So I will show you that briefly. So if we do these two things here, I know that these two are going to be 0.075, and then this corner here, I can have a small gap, say 0.01, right? And it kills the corner for me. So see how it does this, and it's going to give me a small seam to do whatever else I want with it. So delete that, delete the corner, delete this, delete the top and the back. Right, so now I'm left with a situation where I have clearances for everything. Right, but this technically isn't true. I'd have to move this back. You know, I've never actually tried this. Nope, I can't do that. So something like that, and then when you go to thicken it, this has to be thickened outwards as well. So this is the inside outside, because you'll get errors here. So what we were doing in the past, so see where these radiuses are, we have to delete, go forward. We have to create that same condition because this one's come all the way to the edge, but now it doesn't work because there's not enough clearance for all this stuff to work. So what do we do? Okay, well, let's get rid of it all. Right? And then now I could just join these two because the other two aren't joined. 0.075. And look, now I have another spot where I see how far back I have to go on the other one. But I still want this edge here. Like, that's actually my outside edge. Or I can maybe bring it in a little bit if I wanted to. But now I have a spot where I know how much I need to get out of this. So what I once did before was something like this, which allows me to cut down to a certain level, and it should cut into everything else too. Right. So now I have clearance for these two, and I should be able to join everything together. And you could actually take it all the way back to here if we really wanted to. So when we do a full cut, or we could do like a corner cut, something like that. So just kind of think about all the stuff that's in this corner here. So let's take this back just a little bit farther. So how we had this one corner before, is it after we, yeah, I got rid of everything, but it's still all together. Let's try and do this corner, 0.0 or 0.075. So that gives us this corner here, and then the perfect cutout. So that's actually the point that I would like want, or if it's a rip seam, so like if we were going to weld the corners or something like that, you would want to have like something really tight like this. Right? So let's edit that. We can project this point up, take off this one here. Oh boy, never get these right. Okay. Oh, it seems like it's the middle one. Okay. Here and oops, incident to there. So when we go down, it'll just give me a straight cut to here. Cut. Delete. Cuts both. There we go. So it'll leave me with like a small little hole in the corner. And we should have adequate clearances for everything. And everything looks like it's at the the correct side like that and everything. Stitch it back together. Burp. There we go. Okay. And then we can thicken this. Be negative 0.036. Yep. That's outside in. And then we could do convert to sheet metal. We're going to use the bottom. Steel, it's 0.036. And then now we can make a flange in here. Oops. Outside faces. Geez, what are you? This is height datum. Inner, outside. And it's the full adjacent. Yep. Because that's actually the end of where I want it to it, and that's where I want the bend to start. And that should be 10 thou in between there, 0.01. And then how far do I want this out? So from the outside, possibly. We can do, say, a 1/2 inch. And then we could, this is the height, so outer face, so the full outside, so from here to there. Or we want it from the inner face, so from the inside to the outside. So, or we could do the same thing, so to the tangent. So this piece here, I think we want as 1/2. So 464. And then this will be, I'm sorry, here to here. Or here to here. 501. Pick those wrong. There we go. So there's your inside. Let's check that again. Outer faces shortens up a little bit. Outside face to here. So there's 1/2. And then we could say, where is the tangent? To tangent bend, which is, it's going to be the same as the outside because that's where the bend is. So if we did this over, right? See, it grows slightly because it goes to like wherever the tangency of this is. So down this and then to wherever this is tangent on the bottom. So for now we could just say outside faces is probably okay. Outside face. And generally we would do a chamfer, see if there is a like an actual corner. I don't think there is. So just chamfer, and we could just choose how far we want it to go. This is going to simulate just snipping it a little bit, so we could do 0.43, 0.4. Looks like it's good. 0.41. So 0.42 is like right to the edge there. And then if we were to put a couple holes in this based on what this looks like here, so we'll project this whole face. We can say we're going to want these, what, 1.25 or something. These are pretty small. Inches apart. There's the center. There's the center of the tab. We can do center to center. I don't think we're gonna get that out of it. What's one? So one is probably a little bit too shallow as well. We don't need to actually do this, so if you wanted them further apart, I'll just show you really quick here. We can change this dimension or the angle. So we change the angle. It doesn't have to be 45. Do 60, say, and then 0.3. This will be 30. No, it is 60, isn't it? Yeah. 60. And then how far back do we want? So 0.25, 2. Okay. So this is 30, 0.23. .42. And this is going in from the other direction, so maybe we can do we flip the direction? Yep. Actually didn't need to do that. 60, flip, 30. What do I do that for? In the spirit of 420. All right, so that's still in the center. This is still in the center. And now I can do, I don't know, 1.5 or 1.25. This is really small. So I think these are going to be holes. So let's do let's do a 3-inch yeah, actually, you just keep it at the 2. That's fine. We don't have to change the design, hole placement. And then we're just going to make these through holes, and we'll probably use like an 1/8-inch rivet or something like that. So through hole, all, and 0.125, 1/8-inch drill. Something like that. So now we have those two, and yeah, that type of corner. Probably doesn't even need to be 5 thou, something like that. So now that we have this shape, this general kind of outline, it's what we want. We can mirror this whole thing all the way around. Tray, tool tray, before we get ahead of ourselves. So we're going to mirror this piece, mirror plane, we're going to join it. We're going to do the same thing, mirror plane, and we're going to join it. Bam. So to check to see if we did everything right, and get rid of that origin, and we can see if it'll actually unfold. So create a flat pattern. Holy crap, look at that. We did everything right. So there's our flat pattern. And then just unfolding. Oops. Unfolds. Just for shitties and gigglies. Look at that. And yeah, there we go. So that's kind of the idea for that. Go behind. And then now, anytime we want to modify something, it's pretty straightforward. We have a like modifying the height or something like that. Most of these things will be good and parametric. Do I like this corner on the outside? I probably just hit it with a hammer. But there's other ways to it's like just to round this off. So if this was being laser cut, we could just go before this here. Probably a good idea. Just round that off, 0.05, something like that. No sharp corners. Same, and maybe this here as well, because that looks a little bit better at like a 1/2 inch. Even there. And maybe even these things here too. Or just rounding this off a little bit. And it's a little too much. We'll just leave that as a sharp edge. Alright, and all those things will be the same. And if we look at the, you're going to update the flat pattern. And if we activate that, then we'll see what all these things look like in here. A little bit rounder. And these will be square because that's how we made them. Made them square. That's where all the bend lines are. So we'd be bending this little piece here, and then this little piece, this little piece, this little piece. We would fold those two things in, and then we would fold them the other way. So definitely need a box break for this. Anytime there's like a boxy sort of thing. Very fascinating way to do all this stuff here. And you do these separately just so you can have the material thickness difference is the reason why you can't bend this all at once. That's all. And I suppose because it's sheet metal, you kind of can. You make it work, and then you just tap it with a hammer a little bit, like for precise, like if you're just like doing fabrication and stuff, like fabrication for this. If you're doing it by machine, then you have to design your machine movements to handle those things if you don't want to do that, or you just design it like this so that there's adequate clearances. And then even on the inside, so the insides, these tabs here would be overbent slightly, so maybe 95 degrees or something like that, 93. So when it folds in, it's automatically going to clearance, and then you know when the rivet takes holds, it actually puts pressure in the corner. Things tend to square up. So, yeah, there's tons of, oh my goodness, there's tons of different like little things here. But lots of fun too. And you know, like all the stuff that I'm saying is like take it kind of with a grain of salt as well, because there's so many different ways to do these sorts of things with really good outcomes. Like there's no, you know, as long as it works for you, that's kind of the name of the game, you know. So this top piece, we could use a round bar, or we could. I was thinking about just using just a piece of metal tube. And then how do we want to affix that? So let's kind of go through that. So if we didn't want to use welding and we wanted to like sit the handle on there, or if we wanted like a wooden handle, we could just drill through it, like just like screw into the material. So there's an option there, or we could rivet into it. So I could bend a piece, like so bend the bottom of the handle. So when you're cutting, and it would be like just a piece that gets bent down, and then 2 rivets through the end, and then this end piece would hide it all. Or we could do a piece that wraps around this way as well, on the top or on the bottom, so the whole handle sits on top, hollow. Let's think about what we can do here. So the sky is pretty much the limit as far as all this stuff goes. So we do, this is here in the original sketch. One. I want you to go up here. All right, something like that. This will be a new body. Actually, it'll be a whole new component. I'll just go a new body for now, because this is a solid. So we know the position that we want it in. Oops, fillet. Probably something like that. We could take a look. Steel tube dimensions. So rectangle, metals depot, tube sizes, like this is basically what's available. And we can use really light gauge stuff as well. So 16 gauge, maybe the smallest. It's thicker. So 16 gauge is probably the smallest. So 0.065. What's the corner radius? What does it say in here? Cold formed. External radius. That's why I had the 0.25. SHS, RHS. Rectangular hollow section. Hot form sections. Internal radius is 1. Externally, okay, so it's the same as the other. So 0.065. What was that? 0.06. Yeah, that's right. I'll just go 65, and the other one is just a little bit nicer. We're going to shell this 0.065. Eighth inch. The handle probably weighs as much as the box. It's 20 gauge. Could even make that into like a little trough thing too. It's not really nice on the. It's okay to hold because it's like a U channel on the bottom, but it wouldn't be very nice on the top of your hand. That idea. Usually you're going to carry this in the middle. So like the bar that goes around the outside. And I almost want to put like 2 bent plates that go on either side and then just rivet into the middle. So, but because I've never made a sheet metal one of these, I want to see how this typically works. So sheet metal tool tray, yep. Oh, look at that. That was the idea right there. Have like a little thing, a channel on the top. So this is welded. Oh, and they did it on the outside. Okay, so that's cool. I did it on the inside, no big deal. And yeah, so if you did the 2 things on here, and you have like a little top piece to put like stuff in. That's what I remembered from, I don't know, somebody's old stuff anyways. My great grandfather was a tinsmith, so maybe I got it in my blood. Yeah, here's the planning and all this stuff here. That's the ideas. All the hems and the outside and the tabs. Yeah, lots of fun there. Okay, what else do we have? Tool tray. Oh, maybe that's how people do stuff. It's just a U-shaped channel on the top. Sheet metal, yeah, toolbox. That's the next kind of project that I wouldn't mind to do. Yeah, so this is total on the outside. These can be spot welded as well. Also, ooh, I like the leather. That's cool looking. These toolboxes or lunch boxes are coming back into style. Really like that. Oh wow, look at those things, like a tackle box. That's the standard I have. We got a few of these around the house. I guess we could do that. Even at like an 1.5 inches, it's probably okay. 1.5 inches. We use the same sheet. I don't know if that's gonna be. That'd be in 20 gauge is probably not Yeah. Might be a little flimsy. Actually, even this might be a little bit flimsy. All right, we'll make a decision. So we have this. We the fillets are going to be 0.06. I think that's what it was, right? We're going to do 0.036. I think we're going to go up to 16 gauge for the handle because I think that's probably appropriate. It's a little bit thicker, a little bit nicer. .06. None on top. These are outside, so 0.012. So that sheet's all the way to there to the end. Did I make this 3 inches? Oh no, it's still 2. Right. And I'm pretty sure it had flange in the bottom. Where are the other ones? Oh, this was welded. Is there any that are screwed in? This might be welded as well. Yeah, these are welded. Oh, that actually looks like rivets. Oh shit, look, sheet metal project ideas. This is Pinterest? Yeah. That's neat elephant. Oh, that's cool looking. That has the ham, right? All the way around the inside. And yeah, it should actually have a hem. Hem and rounded. Oh boy, this is beautiful work here. Look at all that. Even the stamp. Ah, it's stamped. Okay, that's one of the reasons. And look at all that stuff. So we could do all the way around the edges. Yeah, so the stamped edges. Oh, that's pretty rad, man. You like actually look at all that. So they stamped the one piece and then maybe airbend the sides, or the whole thing actually might be just bent out, and then they riveted afterwards. So this has a inside outside. That's wild. So much you can do. Ah, Pinterest. This, wow. Look at all that stuff, eh? I don't think you can do a hem in sheet metal in Fusion. Yeah, there's no actual like thing for that. So if I wanted to finish this off, maybe this is not the best area to do that. Let's okay. Can I move this down? Oh, there we go. I was like, how come I can't move this? Should be able to. So 1.5 is where I want this on top, and then this would be, where's the center line? Maybe like quarter inch down or something, or even a half or 3/4. Let's do a half. And I'm going to make this 2 inches at the top. 2 inches at the top. And let me round this around. First, where are the mirrors? There we go. No sense having to overwork, right? Now, if I wanted to hem this, what does this actually look like all the way around? And then same with this one here too. So if we hem this, we don't really have to worry about all that stuff. Let's start with this one. We can do this before we mirror. And I'm gonna do a line edge here. Let's do it on this. So a hemmed edge, if I wanted that at the top of the hemmed edge, this is going to have some clearance here into the corner. So it's going to be cut down. And that this will have some clearance into this. So we do grab a drink here. So what does this look like? That's the top. I want to inside 0.039, right? Oh, that's the, no, that's not right. Radius. What I said, 3.9, 3.6, 3.6 and 3.9 was the inside. And I'm drawing this out fully Um, I'm drawing this up fully so that I can get a good idea of where this needs to go and how the hem looks. Because you could do this and then crush it, but that's not. I don't know if that's the correct like look. As far as all that goes. All right. And it comes back down again. And if you were to do a crimp, what does that look like? Let's do. We could just search for it. Hem sheet. Little hem in CAD. How do we represent that in CAD? Right, so there's just it just comes back around. This is what I wanted. I think teardrop is what I'm looking for. Teardrop or the rope. I think for doing this, the teardrop is probably okay. And then the flat hem is really I would say this is for like I would be able to achieve something like this with the sheet metal. Going around that corner up there, I don't think is open hem, and then you press it down. Ends up being a rope hem or a teardrop. And it's thin enough, it's flat. So flat hem. Okay. So I guess we kind of can get away with that. So if we have two sheet metal thicknesses, then I kind of want to have a little bit of clearance between this, maybe 5. Right. This is not correct though. Shit. This is gonna be down further. And then this could be tangent at the top. Great. So that's a cutting surface, and then this is the two pieces that come across here. and then this hem should be X amount long, half an inch from the bend there. So that's a flat hem. 5 thou clearance, just so that there's clearance, and this should be the same as 0.036, and the same as the 2 here. Okay. So if I want this to an object, and then I want to come back 0.125, maybe that's too far. 0.03, something like that. And then I'm going to add this. To here. There we go. Dang. And then I wouldn't mind to do, so up in here, this is going to be an issue, and that's going to be an issue, but we should be able to transfer this hem here. So there is a I should have actually done this as a component and used it to go over. We could have done a hem here as well. Let's do a hem and then a hem, and then you just top the corner so it looks a little nicer. And then kind of same with this too. But if you wanted to use this, geez, I don't even really know. Maybe like a whole bunch of little pie cuts, and then you would fold it over, but that kind of looks like crap. You would have to use a shrinker for that. That's almost, I think that would be almost impossible. So if you do a hem to here, or you just do a sharp corner and you just tap out the edge so it's not like it's not sharp. But if you want to hem the corner here so it gives it strength and provides no burr, on the inside here. Yeah. Yeah, let me think about that for a second. That's a tear hem, and I don't think it's going to work the way I think it's going to work. Although, usually this wouldn't go up that far, I don't think. So this would actually be down a little bit further. I'm pretty sure when you form this, it would go to this line here, goes all the way across, like so, and then this goes down. So we can do it's not great, but it'll work. So maybe we can do like see these holes and this stuff here afterwards, after that. Where is this? 2, 3, 4. So can we do the idea that I'm thinking here is, can I just move all this stuff down before I do all that? And I think I can. So let's do that. This is a little bit easier, just reorienting my operations. So down to there. 2 objects. So the chamfer. Oh, and it deleted the fillet here. 0.06, or is it 0.05? Oh, it deleted them all. Boo. I should put all these things in afterwards so I'm not chasing my tail. You know. Okay. So there's that. And probably do 1.75. Almost 2 inches. I probably could do a full 2. Yeah, it looks good. And the hem looks correct. And there's clearance for that. Beautiful. Could go right to the edge, actually, with the hem. With the ham. Two objects. Let's do right to here. Oh, I did have it right. Okay. Yeah, I like that. That looks really good. And then kind of same for this side here. So I'm just gonna do this is like a interesting way to transfer stuff over. So if I do a new component, I'll just say hem pattern, hem. I just call it hem. Where is the hem? So the hem is usually here. We're gonna just move the hem if I can. Is this grounded? Oh, it is. Boo. And we're going to use the almighty joint. We're going to joint this to, I don't know, where should we do this? It doesn't really matter, but maybe we can do to this edge here. And I want that Z up, and I want the X direction on top, or horizontal, positive to the right. Okay. So then when I do a, making the sketch inside this one, and I'm just going to copy this. I can actually copy the original sketch too. So all this stuff here, if need be, because then I can join it based on this sketch. So turn off the body. Turn off the body. Turn on the sketch. Right. So that's all the stuff that I need for this. That'll be there already. There's the outside. I think that's pretty much all I need, because that's what I'm adding to it. And this is what I'm getting rid of. But that is, I think, probably where I'm going to put the thing. So let me recorrect that. If I can actually do this here. Get rid of this. I want this to be on top. Just like that. Go into the hem, go into the sketch. Edit. Right? So when this only works, it's not, as long as the thickness doesn't change of the different materials, this will all be the same. So that's the hem that I want. Okay. So I have one hem. It's jointed into place, not moving. Yeah. And that's on the end. So, Carzy, why'd you do all that? Well, I have another piece here. So if I don't ever want that hem to change, I can make another version of this. You sneaky bastard. And I can move this over here. I can turn that on, obviously. And I can joint this along this edge here. See how like the edge sort of changes? Let me get in here. Or like that. Shh. Don't tell anybody you can do this. So that's what this hem looks like from here. And this is sort of okay. So what we can do is we can delete some of this stuff first, because we have something to work with here, but we're still in this main sketch, right? So we can base our sketches off to, like, instead of redrawing everything, we could just say, well, on this plane that's referenced from here, creating a new sketch on the main tool tray, and I can intersect this whole body, to get this stuff here, right? And then I can say just project everything that's in this sketch, or I could just use it, but this is a little bit simpler of a way to do that. And then I can turn off these things, and all that information is now here. I didn't have to redraw everything, and if I change this hem, this one will also change. So this is cool because we could say, okay, I want to do, oops, not that one. That's going to be left over to here, and then across, right? So we can say we're going to delete all that shit, or maybe it's 0.03 Zjazove. Right. So it's going to cut that out, but that's where I want to start. Or I could just do the whole cut all the way to here. Moving on up. 2 objects. Right? And then I need clearances for each one of those. So I'm just going to do that again. Same thing. Right? Because I have the other side. And I'm adding to this hem all the way to the end here again. Wherever it ends. I was going really slowly. So 2 objects. It's going to go all the way to here, but now I want a little bit of I don't know, like clearance, I guess. So I'll make this go back a little bit. So offset 0.06. 16th. Something like that. So that works correctly. And then now I'm going to have to deal with this in here, because that's not how that looks. This has to be like a square cut, and maybe even some relief under here. Or I can just tear it, either one. So, but because I went all the way to here, like that's kind of what that looks like. So maybe not this one as the first one. We can do, I didn't actually think about this the first time. So in this sketch, it's sketch because we have one and then we have multiples. So if we did this multiply, I can say all the way over here, let's do horizontal, vertical, trim. So now I can trim that all the way over, right? And then maybe all the way up as well. Something like that. I could just add all this stuff in. It's like not a huge deal. Or I can overbuild it. You know what I mean? So if this was, if I just want something to trim, I know it's always going to be like that. We just have this over. Sometimes this does less damage as well. This is equal to this. And here's the beauty of it. Go back. This one also is going to be the same. Like that. So before we get started on this second one with the hem, we can go back and say all of this I want to, not you, that. Oh, I didn't project it. That's why. I'm working in the different sketch. I'm like, what? Yeah, so good way to double the sketches up and, or double. Good way to reuse multiple things. So I've cut all this stuff away, and including the clearance that I need. And then when I go to remake this thing, I can make the offsets kind of like in the spot that I need them. So there's that piece. These are going to join in. I'm going to do all the way to the edge here again. So two here. But now I'm going to do the 0.03. I'm going to offset also 0.03. Oh, I'm sorry, negative. All right, so that gives me 0.03 gap on each side. And I suppose that's okay. Get rid of the last one there. We don't need that. So that is a good way to do those two hems. We could just turn those off. Turn off the joint as well. And the last little sketch. Delete. I don't know what that was about. I think those were the ends of these things here. Let's get rid of those, see what happens. So it looks pretty great. Two hems there in the corner. Hemity hem. This would also almost be a sheet metal. Is like you would just like tap the edge there. Usually this would be, because this sheet is so thin, a lot of the times it's not really needed to draw in. So you could actually draw it in as a tear. But if I want this to unfold, I need a small gap in between. So to do this one here, I could say 10 thou on each one would be sufficient. And that's just to make the CAD program work, essentially. But like if you were to snip this, you snip it right to the end. Like a little, like 10 thou is it's like one of the little tiny serrations maybe on your shears. But if this was laser cut, then it's, you know, like this 10 thou is not even the kerf of the laser. I think it's 40 thou. So it's four times larger. Or maybe it's 4 thou, I forget. No, it's 40. 40 is usually normal. So like if you were to make something like this, it wouldn't go back into there anyways. It would just be you know, clipping over nothing here. So now I have these things here again. I don't have to redo these necessarily, depending on where they are. So see how this is here, but I can do this bevel on the top.
Or I can just do the chamfer myself here. Oops. This is overdoing it, I suppose. Something like that. Get both of those to look nice. And then I could do a flip up and then two in the middle. Or I could do one on each side. So flip both of these in. They each get one. And then down. Or I could do both. So flip this one in, and then flip a big one up, and then it's a triple all the way through. 1, 2, 3. That would actually look really nice if we could do that. That would be really, really nice. Let's try it. Let's do. This handle has to be its own thing. Can't be in with this if it's sheet metal. Yeah, look at that. It unfolded and everything. Even the hems. Beautiful thing. Great. Do a save there. Hey, thanks cheap viewers for showing up today. Appreciate that. You showed up around 3:30. It tastes so good with just standard water. Man, oh man. So I have this and then the round, and then I could do another hem on the top as well, but I would have to put this all the way around, and I don't know if I really have to or not. I don't know. I think that's okay. I gotta go prep dinner here in about a half hour, so we should be able to get this done. You know what's funny is that sometimes it takes just the same amount of time to do the CAD work that it does to actually make the thing. Like if you have all the tools and all that, like a lot of the times, unless you're building hundreds of these, you know, hundreds you would definitely benefit from laser cutting. But if you're only building 10, I don't know, you could just you just draw one out and then you cut out the flat sheet and then you just draw the templates and mark all your stuff. Mark all your bend points and things like that. Like, I think that's pretty straightforward. But like if you're doing CNC bending and like batch stuff, and you're building hundreds or thousands of these, well, yeah, there's I wonder. So you could deep draw that corner in steel, but bending it over, you're not going to shrink that material enough without it looking funny or having some sort of sharp edge. I guess you could do it, but it's not really worth it. You're better off to polish the edge, like to do welding or something, or you use a thicker material, like just on the edge here. But the hem is really nice. All right. I guess we're going to want some hems on top here too, right? Let's finish this. Where's the... Oh, we just don't have the dimensions on there. 0.75? No. 0.75. Down a little bit. And this will get this hem in here. So... Oh, nope, that's not right. You... And the inside. Right there. So, similar sort of thing. So 2 objects. So that's the full cut. And then I can do this. 2 objects. Similar sort of thing. And offset negative 0.01. 10,000 and offset 0.01. Right? So I've got a hem at the top there. Oops, I forgot to do the other little quadrant. This is not a new body, this is join. Right. Right, so the hem at the top there. That looks good. And I'm going to do a hem on each side of this. But first, I'm going to convert it to a... actually, where's my... U and U? I'm going to delete that. Everything still looks good. Yep. Oh, you know what? I could have done this beforehand. It's 1 inch deep, 1.5. And when I do this, I'm going to symmetric I'm only going to do one side. I'm going to do to objects, and it's going to be a new component. And then within this new component handle, I can make all the ends and stuff on there. So what's interesting here is that I can double up the material here, and then I can double it here as well for more strength, and then move this up a little bit. But yeah, I kind of like it like right here. Let's move it down just a little tiny bit more. Yeah. Yeah, it would be kind of nice just to put it right up to the top there. Yeah. Here we go. Perfect. Problem solved. Just a little bit wider. I was like, hey, wait a minute. I have like design space here. I can do whatever I want. I can do what I want. Update that. Just check it out for time being. Yeah. Y'all. Handle. From the bodies. Turn that off. We are going to we're going to say we're going to make this out of 0.6. If we make it out of 0.03, it's going to have the hem on the top, and it will be fairly strong. Doubles the material. Yeah. 6. Yeah, it's 0.05. 0.075. Am I only doing 2 of this too? Yeah. .036. And similar type of situation for here as well. So why don't we explore doing... We're going to do the triple fold again, I think. So a half, maybe a full thing, and then the half and a half. And that way each one of these surfaces is attached to the thing. And it's going to be extremely strong. So this is where I want the surface to end up being. The hems are going to be back a little bit further, so that'll come afterwards, I think. We'll do that last. And let's convert this to sheet metal. Convert to sheet metal. Let's do a sheet metal. Let's do a flange. Let's do the other side. Go up to here. Let's do inside. Because that's as far as we want to go, right? And height is outer faces. Yep. So we don't want any go higher, any higher than that. Full edge. Let's do outside. We're gonna flip this. Bend position. We're gonna do adjacent or outside. So this is where we need to. I'm sorry, I did this backwards. I want to bring this in. So 0.36 plus the sheet metal's thickness. So plus the 10th thou. So 0.085. Yep. And then to test that, oops, flange, flip. It's up to there. So these are going to be, turn the sketches off. Oops. Flange. Flip. So that's exactly what I wanted to have happen there. Except we're gonna do where's this site here? This is D57. D57 divided by 2, and then we're going to minus 0.01 from that. And we're going to do that to both of these. So that's on the outside, we're not going to see that. And then hopefully when we make this, next one here, and then this one's going to be on the outside. That is also going to have 10 thou maybe in between it. If I did my stuff right here. 0.013. I did not. So this manus into here is at negative 0.075 is more, sounds more correct. I added an extra 10th for no reason. Maybe I didn't. Hang on. So inside faces. Inside faces. To the inside. Right. That's pretty much bang on, right? So the thickness is 0.036. What did I say this was? .0336. But the radius is 0.039. Oh, okay. So it's 0.039. 0.039 times 2, 0.78. No, 0.039 is the radius around. So there's one on the inside. So 0.36. So 0.46 is how far I need to go out. So 0.46. So let's go back to that. So negative 0.046. That's perfect with 10 thou. Now, if I was to create a thing right here, this should have 10 thou. Sometimes I overthink it for whatever reason. Yeah, it's perfect. Perfect. And then this one is up to here. And that's going to be height datum is outer face. Because that's outside to this side. Outside. I'm going to do 0.05 on these ones instead. 05. So I said. There we go. So 10th thou gap between the two, 10th thou gap between here, and then we can shoot that in. So form 1, form 2, form 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7. Okay. And we can do 4 rivets on here or something. Or even just 2 big ones. Feel like I'm too smart for my own good right now, but I know this is just industry standard. Alright. Alright. That looks really great. Oh, and we gotta do the hems. Let's not forget the hems. And that'll be basically right to the edge there. A little bit of gap. So we got an end. Turn that off. We're on that. Let's go to there. Turn the hem 4 on here. Oops. This should not be. Oh, can't make a recovery file? Well, that's not good. Plop this dude right on the end of the inside here. Save this before it's too late. Okay. distance to objects. Two objects. And we're coming back 0.01. Maybe 0.03. Nah. We use 0.01 for everything else. As long as it's not touching. Is it touching? Ah, it's touching. Of course it is. So woohoo. Alright, and I'm gonna try and mirror all this stuff over, although I don't know if it's gonna work because of sheet metal. Never tried it. So these two. And look at that. Oh, it's a beautiful thing. Can we create a flat pattern for this? No, it's already sheet metal. Oh, look at that. Beautiful. I love it when that happens. Okay, and then still don't know if it's going to work or not. Airplane. We're going to join. Oh, look at you. Okay, so before I do that, let's punch some holes in this bad boy. How far down? 0.5. And let's try and do center to center. There we go. That's awfully close, but I think it's okay. And then we're gonna do a hole through all. We might have to mirror the things as well, because they don't cut on the other side. So we can do the handle and all of this to get the holes in this before we do the last mirror. We might be able to do that. So all of this is to here, or we created that, but we created that from this sketch as well. And that was here. So let's see if we can do that. Yeah, there we go. Beautiful. Crazy, crazy, crazy. So let's okay, that's updated. Ooh, it was on an angle that shows so hem. So can we make this? So we do the hems first usually, and then 1, 2, 3. 1, 2, 3, 4, 5, 6, and then 7, and then 8. Yeah, it's buildable. Buildable. Let's do that flat pattern again. Okay, good. It's still straight. I thought my UCS was on an angle. Sometimes when it reorients like that, it means it it's a no bueno. Okay. Looks good to me. Maybe we can put some body. Turn the UCS off on here. Origin. So in order to do to make this like extra strong, we could put some bead profiles in this. Certainly on the bottom here, that would make this extremely rigid. It wouldn't like, you'd do either way because there's a 90-degree corner here, which makes that fairly strong. But the long way, because this is the long way here, when we go to pick this up, it wants to kind of like curl into itself. So we would want to bend straight up. Yeah, it's gonna want to bend. So having the beads the long way would probably be beneficial, even if it's just like 2 or 3. Inside or outside. Outside, the beads would have to be pretty precise. Inside, it doesn't matter. Except nothing sits flat on the inside. So if it was on the outside, it would actually raise this up a little bit. Might not be a bad idea. Can also just do like an X, like a form, and then again, still it's never gonna sit flat if I do that, or completely flat. And then things on the inside as well. A little sore there, I think. Like that. Oh. That's pretty cool. Let me see if I can put a rivet in here. I haven't done rivets, I don't think, in Fusion. Let me do a rivet. Oh, they do have rivets. Great. Planes, fine. I don't need a structure rivet. They have a pop rivet. Or an aircraft rivet, maybe? Come on. You know, I don't think I've ever seen a hard rivet done like that, like a small one. Sheet metal. Aircraft rivet? Is it just like a press? Because those are the blind rivets, like pop rivets. blind rivet? Riveting in a bucking bar. Oh, is it literally just done with an air hammer? Oh shit, it is. Oh, ain't that something? Learned something new. Steel? Oh, ain't that something? One and a half times. Oh wow. Interesting. So we'll just do a button header of it. Can we go really small? No, that is not the right one. That's funny. Let's do Imperial Plain Rivet. Countersunk would be kind of cool, but I just didn't prep anything like that. So, small solid. Ah, cool. 1.5 times material thickness. Clicos. Update. Smush. A sheep shank. Update. Uh, Lots of jargon, that's for sure. Holy moly. Yes, definitely we're hearing production. You got a $400 kit, so the hammer is going to be air hammer is going to be extremely good. Still though. I'm fascinated by the solid rivet. Oh, you didn't deburr. He did deburr. Good job, though. Sheet metal is really cool. Right on. Thanks, Hot Rod. Hot Rod hippie. Psk. I just saw him. He's like, he pushed it right through. But oh man, that's really funny. Ooh. Shit, I'm in a rivet rabbit hole now. No. A pierce rivet? Why do people drop things in the ground? It just this doesn't mean anything. So stupid. Like a hen wrap fastener? Oh. That's a high rivet. Schmerp. Why does all your tooling look brand new? uh oh my. Wow, there's like a whole like look about this stuff, I guess, right? That is a lot of holes. Pretty. Oh my god, 236. Bro. Hour or two of practice. So a couple hundred rivets. And you'll be a pro. Alright. I don't know if we can make this look like it's make it look like it's installed, I guess. Anyways. Well, that's the toolbox thing. Some fasteners in there. We got the hands, we got the handle. The triple thing up here. Yeah, I think that's pretty cool for the trough. Yeah. All this has a flat pattern to it. So you can cut this out and do the hems. You have this done for you, maybe. And then also the handle. Where are you? Flat pattern. Where are you, flat pattern? You're my only hope. So this one's here are hem, bend, 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 and then do the final bend. So this one and then this one. Then you'll end up with a shape that looks like that. Looks like this here. And then you could drill your holes through, or drill the one hole, drill the other hole. You might need to, that's only 1 inch apart, so that's pretty small. Not fastener sketches. Where are my sketches? So there's only 1.5 inches. I might even be able to make that. Well, 2 inch twitch handle. Inch and a half, pretty small too. Even like 2.5 inches. 1.5 inches is pretty significant. That's about a handrail, 1 and 5/8. If we did 2, 2 looks better. But 2 is like, it would be awkward to hold. It would be awkward to hold like the handle. 2x1. But if this was like 2x, well, yes and no. Two by two. Big handle. Big square handle. It's a little bit too big, I think. Something that's 2x2. It's 2 inches deep. That's 3. I was gonna say that's a little bit. It's a little bit too big because you want to be able to get your fingers around it. So yeah, 1.5 inches I'd say is the absolute deepest. 0.5. 1 is good though, I think. This is 1 inch wide, right? Yeah. Double check the turn on the bodies. There we go. Yeah, looks okay. It's nice how everything updates, right? Update the flat pattern. update that flat pattern, and we're good to go again. So I can finish this up and maybe throw this up on the website, maybe make that a freebie, and then you guys can go from there. And the rivets, fasteners, this one side. Fasteners didn't want to insert last time for whatever reason. Make that a save just in case. Plain, I did small button header, right? Auto. Quarter. Delete. One on each side there. Right on. I'm gonna go make some dinner. You guys should probably go make some dinner too. It's almost dinner time. Unless you're on the West Coast, then hope you had a good lunch. Gonna take off for a little bit. I might be back later on. We'll see how I feel. Have a nice afternoon, and we'll do some more stuff later. I got what else do I got on the list? That's not the right one. Sheet metal ideas. So the tool tray we got. Strike through the toolbox. Yeah, maybe we can do a toolbox with a hinge or something like that. And a lunchbox. You can do an ash pan and dust pan are pretty much straightforward. We can make a grill. Do a whole bunch of these like the wire actually not the wire rack and regular is kind of the same. I actually built wire rack when I ran my business. I gave it away. I scrapped it because I didn't have room for it when I moved. Hopefully somebody got some good use out of it. It was like I made it out of 1x1 steel. There's casters on it. It was pretty nice wire rack. 3-level. 3-level. Jeez. So maybe we could do like we'll do a shelf afterwards. Maybe at a like 1/8 inch or something like that, like aluminum or stainless steel, something like that. It's turned out really well. I'm really happy with it. This would be really nice to put like a couple beads on each side. Maybe add some beads to this. But so far so good. That would be like a fun project to try and do at some point. But yeah. All right. I'll catch you guys later on. Have a